So let's remember what we've been talking about. If you have position, you take the derivative, get to velocity, take the derivative, get to acceleration. Today, we want to be able to go backwards, and backwards from taking the derivative is integrating. So if I have acceleration, I can integrate to get to velocity. Once I'm at velocity, I can integrate to get back to position. The only problem is when we integrate, they're going to have to give us some kind of clue so we can solve for C. We don't have that issue coming down because the derivative takes C off, right? The constant will turn to 0. Here, we need to get that C back. So they're going to have to give us information like at 7, if X is 7, Y is 10. Somehow we have to be able to plug an X, Y in to get to that C. Okay, so let's look at this. That looks scary. It's really not. This is just what I hand wrote on the back. You have position, velocity, acceleration. And you guys already know your equations, feet or meters. We have our standard equations. These numbers right here represent gravity. So on planet Earth, those are the same. If I send you to the moon, I have to give you some clues. Okay, let's look at this. Now, all these you have already looked at. The ones that I'm adding in today are the integration ones. So let's look at what's happening. Velocity, acceleration, speed haven't changed. Average velocity. Now I want you to think about the words, right? We said everybody here wants your average up. Even if you have a 99, you want 100, right? So when we had to use average velocity, we went up and used position because for average, you had to go up. The alternative now is you can integrate velocity. If you integrate and you want velocity, you just use velocity because what does integration do? It takes you up. The integration sends you up itself, right? True? Okay. Let's look at average acceleration. This was yesterday. You all said you want your average up. So instead of using acceleration, we used velocity. If you use the integration symbol, then you can just use acceleration because again, what does this symbol do? What does the integration symbol do? It takes you up. If you're at acceleration and you integrate, you're now at velocity. If you have velocity and you integrate, you're now at position, right? So displacement, now this is a nice one. For displacement, we used to have to use position because it is a position. If you want to integrate to get to position, what do you use? Velocity. Because again, what does integration do? It takes you up. So if you want position, you would integrate velocity. Now, total distance, you're going to like this one because instead of having to do the start and the end and all the stops in between, you can just put the absolute value in and it will add them up. Remember, this symbol, the symbol for integration, really is a fast sum, right? It cuts it into infinitely many intervals and adds them up really fast, right? So that is a sum formula. And then position at B, like if I want to know what's happening at 7, I could do position from A to B, and I want to know where it is at B. I could do position of A and then integrate. Now, do you need to memorize this? If this were last year, I would say absolutely, because I'm going to give you a memory test over it. This year, we don't have that because you have access to your notes. You should try to remember it, but of course, can you have that out while you test? The answer is yes, right? Okay, let's look at some justifications. What this means is, why does that happen? So a particle is moving right or up because velocity is positive, right? You already know that. A particle is moving left when velocity is negative. A particle is speeding up when velocity and acceleration have the same sign. A particle is slowing down when velocity and acceleration have different signs, right? You already know that. True? True, 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 true. Okay, then we're going to look at some problems. Find the displacement by the particle during this interval and the total distance traveled during the interval. You're going to use your calculator for these, right? And how do I find displacement? Let me get up. What is displacement? What do? I just type velocity in with the integration symbol. You don't know how to do that yet because I made you do them by hand. How do you do that? Math 9. You're going to love this and say, Ms. Coughlin, why didn't you tell me years ago? Whoops. I'm going to clear my calculator. Second plus 7, 1, 2. I like to start with a clean brain. So math 9, look at that. It puts it in for you. Where your brain work comes in is you have to know what equation to put in. And if you want displacement, what do you integrate? Just look at your front page. What do you integrate for displacement? Velocity. So let's write that down. Integrate, right? Write down what you're doing so you'll remember. If you write this down 10 times today, are you better off? Yeah. So displacement, that's how you do it. So you just say 0 to 3. You type in velocity. Is it okay if I use X? Of course it is. My calculator doesn't know what letter that is. And remember, you always have to tell it right here what letter you used. So where you see that D and the flashing, you have to put an X in there. And then you just hit enter. There we go. How do you like that? It didn't tell us whether these were feet or inches or whatever, so I'll just put units. All right. Total distance. So look back to your page. How do I find total distance?
Check to
Absolute value, right? Okay. So I'm going to do that in a different color. Again, if you'll rewrite these down, it will help them stick. Of course, you have to go from A to B. I should put that on here. Really write these down. All right. So what do I type into my calculator? 0 to 3. That's it. So write down what you're going to punch in so you don't forget about that. Again, that's what? Math 9. So I'm going to go from 0 to 3. Whoops, hit the wrong thing. There we go. How do you get absolute value in? Math number 1. There's other ways to get it. That's one way. So x squared plus 3x minus 10. And of course, over here, you need to tell your calculator what letter you use. It's going to match whatever's here. And you hit enter. And it's going to think. And there we go. How do you like this?
How did you get absolute value on the calculator?
Okay, it's math over to number and number 1.
Thank you.
You're welcome. You can also do it. Another way is alpha window number 1. That might be faster for y'all now. Alpha, oops, I did it twice. You can hit alpha window 1. And that's another way to do it. There's several ways. So alpha window 1 for okay. Easy. Is everyone successful at typing that in? That first exercise was just, can you use the calculator, get it typed in? How did you do this problem earlier in the year? What if you didn't have a calculator? Let's just review that real quick. What would you do? You'd integrate, so it would be what? You'd go up 1 and divide, right? Plus 3t squared over 2 minus 10t. And then you would plug 0 and 3 in, and whatever you got for 3, you'd write that answer down minus the 0, right? Do you remember that? So that's integrating by hand. You have to power up and divide, and then you have to plug your 3 and your 0 in. It's much easier with the calculator, right? Okay. If the acceleration function is at equals -4 and v0 equals 12 during the interval 0 to 8, find the total distance traveled by the particle. So what is total distance? What do? How do we get from acceleration to velocity? Come on, guys. How do you get from acceleration to velocity?
Integrate.
We integrate. So we're going to integrate -4, right? What do you get when you integrate a constant? When you well, I don't want to write that again. When you integrate a constant, what do you get? You add the variable, right? And you have to add c, correct? Okay. Now, how am I going to solve for c? If this is acceleration, what did I just find? What is this? What do you get when you integrate acceleration? This is now velocity. Let that sink in. And how can I solve for this? Let me rewrite this now. Right, I found velocity, but I don't want that c there, do I? Don't I want the actual number? So what can we plug in there? Velocity is 12 when t is 0. So what is c? So velocity is actually -4t plus 12. So we did have to do a little bit by hand. Once I have velocity, can I find total distance? Let's think about what that means now. I want you to think. Total distance would use what equation? Is it position, velocity, or acceleration when we say total distance? That's a position thing, right? True? And how do you get position out of velocity? You do what to it? Integrate. So total distance must be velocity integrated. Now I'm allowed to look here and look at there. There it is. So we need this. Let's write it down again so you get used to it. Right, so now we're going to plug it in. It says during the interval 0 to 8, find the total distance. So what am I going to do? 0 to 8, and I need the absolute value. Right, so now you're ready to punch it in. Punch it in. So you can't totally rely on your calculator. Sometimes you're going to have to integrate to get there. But once you have the correct formula, then you can punch it in. And what do you get when you punch that in? I think I got 68. Y'all double check me. Is that what you got? Did you? Did you? Did you? Did you get it? Did you get 68? Okay. Any questions? So what is your thought process today? You have to look at what you're given, correct? And you have to decide what you need. If you need it to go up, then you're going to integrate. If you need it to go down, you're going to take the derivative, and maybe you just need what's there, right? Is this easy? What happens every time we say it's easy? We throw a cosine in there. Woohoo! Now, I don't know if I gave y'all a third page. We're not going to do that third problem. We're just going to do this one. So what does that say? The velocity of a function of a moving particle is Vt equals 3 cosine t for 0 to 2 pi. That's one time around the circle, right? So you're very familiar with this. So now we got to find all these things. Determine when the particle stops. When does the particle stop? Let's do our justifications. When does a particle stop? When Vt equals 0. Determine when the particle is moving right. When is the particle moving right? Right? You should always, on these problems, think about what's going on before you do it. Analyze what you're doing. Total distance traveled by the particle, well, we're going to have to figure that out. What about speeding up? Sine of Vt and At are the same. Now, as far as total distance, what is the total distance? Total distance was the integration of velocity, right? If I have access to velocity, and I do because they gave it to me. If I didn't, I might have to do the beginning, the end, and all the stops, but I don't have to do that. This just says if 0, 5 is a point, then find 6. So there's not a rule for that. Okay, here we go. Determine when the particle stops. What do we do? Set it equal to what? Now, can I divide out the 3? I can. Most of you would just do that with your eyes, but I don't want anything left to chance. Now I have to pull this out of my brain because I've already memorized this. Where does cosine equal 0? Well, it equals 0 here and here, correct? And what are those spots? Pi over 2, 3 pi over 2. So that was some prior knowledge. I had to know that, didn't I? Now I think you're going to like trig. It's actually easier than regular numbers because you already know where stuff happens. So this goes from 0 to 2 pi. Whoops, I started to say 2 pi and I wrote it down first. Okay, so tell me on this chart at pi over 2, we're 0, right? And at 3 pi over 2. What's a way for you to think about this line? Instead of thinking about it as a line, what do you guys think of? A circle, and you think of 4 what? Quadrants. So this is really quadrant 1, true? And then this would be quadrant 2, and then quadrant 3. There's not a stop between 2 and 3 because cosine gets to pi, right? Think about. And then quadrant 4. What do you know about cosine? It's positive, negative, negative, positive because it's x, right? So what are your signs going to be? Positive, negative, positive. So with trig, if you think about the unit circle, do you have to sit and plug numbers in, or do you already know the sign order? You already know the sign order. It's kind of free. So where is this moving right? You told me it was moving right when velocity was positive. So it's going right from 0 to pi over 2, right? And 3 pi over 2 to 2 pi. And actually, we could put a bracket here because when it gets to 2 pi, it is not zeroing out. It's at 1, so it's still moving. Okay? Nice, not too bad, right? The trig is kind of better. Did I hear you say you missed trig? Okay, I didn't, but I'm pretending. C, determine the total distance. You now have a new friend, the absolute value of velocity. So, okay, wait. If I want total distance, why am I using velocity? We're using velocity, but we want to go up to position. So what are we doing to the velocity? By, what's our verb? Integrate, right? So if you integrate velocity, and I'm going to write that down again. After all, I'm just a kid. If I integrate velocity, I want you to really put in your brain that when you see this symbol, you're going up, right? So if you integrate velocity, you're getting position. And we want position because we want distance, right? Distance is a function of position. So let's do this. Where are we going? 0 to 2 pi. And we're going to do the absolute value of what? What is our equation? 3 cosine t dt. Now, if you are using a pi button, what do you need to make sure your calculator's in? Radians. It should be in radians if you've cleared it. So go ahead, take a second and punch that in. How do you find the integration symbol again? Math what? Math 9. And then we're going from 0 to 2 pi. Does everybody know where your pi button is? And then where do I get absolute value? Math number 1 or alpha window 1, whichever way you like it. And it really does help you to keep typing those in so that you don't forget them. Now, are you allowed to use the letter X? Of course.
How did you find to turn on radians?
Mode. You always want to make sure under your mode, you're either in radians or degrees. To use the pi button, you've got to make sure you're in radians. What do you think? Is this nice and easy? It is, isn't it? Who would guess trig was easier than the other stuff? Right? Okay. E. Oh, wait, D. We've got to find D. So if x of 0 equals 5, find when x is 6. What do I do there? Well, I have to integrate, right? X represents what? Is that acceleration, velocity, or position? It's position. Why did they give us this point? What's the reason for that? So we can find the C. Very good. If they want us to integrate and find a new equation, can't use the calculator because we're not just wanting an answer, we're wanting the equation. They have to give us this information so we can solve for the C. So we're going to integrate 3 cosine t. And what do you get when you integrate cosine? Sine. The constant just stays there, plus c. Now we need this information so that we can solve for c. So 5 is the y. So let me write this down. I want to make sure when we integrate velocity, when you integrate velocity, you get position. Remember, right? When you integrate velocity, you get position. So this is now position. And they gave me a clue. They said position is 3 sine 0 plus c. You knew this probably had to be 0 because we know that we don't have a sine of 5 ever. So what is sine of 0? Zero, right? At 0, sine is 0. So what does c equal? Right? C equals 5. So now we could say x of 6 equals what? 3 sine what? 6 plus 5. Punch that into your calculator. And remember, that's taking the angle. It's not saying sine gets that big. And what do you get? There we go. So you've got a good example now showing you when you integrate, you get a plus c. They have to give you a point. This allows you to solve for c. It's our one bad part about integrating. We have to find that c. All right, now E. When is the particle speeding up or slowing down? So I'm going to do velocity and acceleration. You know I like my charts separated. 0 to 2 pi, 0 to 2 pi. Now I already did velocity, right? Now what's acceleration going to be? What do you get? How do you get from velocity? If velocity equals 3 cosine t, what is acceleration? What is the derivative of cosine? Negative sine. So now where is sine? First of all, where is sine 0? At 0 and pi, right? Now where is sine positive? Think about sine. Sine is positive in the top, negative in the bottom. So from 0 to pi, acceleration is going to be what? Right? Now, that is a negative, but I could say 0 equals negative 3 sine t, right? And I can divide that out and say 0 equals sine t. So that negative went away. We got rid of that. So it's 0 at pi. And then sine is positive here, negative here. It was nice not to have to figure it out. We already knew that. The question's asking, when is it speeding up? It's speeding up when the signs are the same. So right here, and right here, correct? So what is that? 0 to pi over 2 and pi to 3 pi over 2. Easy? If maybe not easy, I mean, it is honors calculus, but if you had this paper out, could you do the work? If you have these examples to look at, can you do it? Yes, you can. So let's look at what our homework is today.